We had somebody ask about this problem, so I can't resist doing it, even though it's my least favorite problem in section 2.5. It's number 11, and the reason I don't like it is that it's much easier to solve this question, or answer this question without linear algebra. It's really just a probability question, but I'll take you through how I saw it. Some of you may have seen it differently. That's fine. So the question asks, in a population of 300,000 people, 90,000 are infected with a virus. After a person becomes infected and then recovers, the person is immune, cannot become infected again. Of the people who are infected, 4% will die each year, and the others will recover. Of the people who have never been infected, 20% will become infected each year. How many people will be infected in 4 years? One of the problems with this question is that it actually wants a snapshot of how many people are infected in the year 4. Usually when questions are asked like this, they're asking the accumulation of the number of people infected. And that's why some of you had trouble. I hate this question, and I'll delete it next year, and I apologize you had to suffer through it. So here's how this works out. What's strange about this, as I said before, well, I may not have said it, is that once you become infected, you're immune. You're either immune or you're dead, and that's what makes this so much different from other problems. So I just did a nice old-fashioned probability tree, and so we have 2 cases here. The first one is that you're infected, and the second one is that you're not infected, right? So we start out with 90,000 people being infected and 210,000 people not being infected. And so of those 90, you can either recover or you die. Okay, so this is recover or dead. Now, the probabilities are 0.96 that you recover and 0.04 that you're dead. So if you multiply 0.96 by 90,000, you end up getting 86,400. And then down here you get 3,600. And if you add those up, you'll get 90,000. That's good. Now, what's wrong with this? Once you recover, you can't be infected again, so I'm stopping on that branch of that tree. And here, once you're dead, you can't be infected because you're dead, right? So the only people left to deal with are these guys, those not infected, and this represents year 1 right here. So of those not infected originally, what happens in year 1? Well, they can either be infected or not. The probability that they're going to be infected is 20%. The probability of not is 0.80. And so if you multiply 210,000 by 20%, you get 42,000. And if you multiply 80% by 210,000, you get 168,000. Okay, so that's where we are. Now, if you're infected, right, we learned this last time, you can either recover next year for the next year's reckoning, right, or you could die. And it really doesn't matter whether you recover or die, because for this problem, I'm only concerned with how many are infected exactly in year 4. So what I'm going to do is just continue on this way, and I'm not going to do all the calculations except for those that are necessary. So notice that this branch of the tree down here, this represented people who weren't infected. And in year 2, that's what this represents, year 2. I have the I can calculate how many were infected, 20%, right, of 168,000. That's 333,600. And then not infected, that's 80% of 168,000, 134,400. The numbers aren't really that important. But remember, so this is year 2. Year 3, it's not going to matter for year 3 because this guy up here, because once you were infected, you're either immune, you're stopped out by being immune, or you're stopped out by being dead. So we're almost there, because now I realize what branch of the tree I wanted. So we either have not infected here, and remember this was not infected, this was infected, right? Wait, I spelled infected, I-I-N. I might be infected, hold on. Infected. And so really, this is so easy now. So the non-infected, all I have to do is multiply 134,400 by 80%, and I get 107,520. And now I know exactly what branch I'm after. It's this one, because of the non-infected in year 3, we have either you're going to be infected, and that's 0.20 times 107,520. Okay, so I get 21,504 people are infected. Now, the point of this problem is not to do the entire tree, but just to get an idea of which path you're after. Okay, so notice that I'm taking 210, I'm multiplying it, here's my path, right? I'm multiplying it by 80%, and then I'm multiplying it by 80%, then I'm multiplying it by 80%, then I'm multiplying it by 20% to get here. That's my path. So all you have to do to solve this problem, and some of you saw this immediately, that's good, and if you didn't, it doesn't matter. Here's the probabilities I'm multiplying together. Oops. If I multiply the probabilities together, I get 21,504 infected in year 4. And that's your answer.